Let's look at some other transformations. This time we're going to do reflections. So we've already talked about horizontal and vertical shifting, and now reflections are both referred to as rigid transformations. We're not changing the size or shape of our original parent functions. So let's jump right into an example. What if we wanted to graph h of x equals negative x squared? So first, let's graph the parent function, which is just y equal x squared. So input is x, output is x squared. So when x is 0, we square it and get 0. When x is 1, we get 1. 2 gives us a 4. 3 gives us 9, etc. Negative 1 also gives us a 1, and a negative 2 gives us a 4, and so on. So let me plot those points. 0, 0, 1, 1, 2, 4, and then 3, 9 is off the grid here. But we get the idea. Goes up pretty quickly. So that's our parent function y equal x squared. Now we want to graph h of x equals negative x squared. Now it's important to understand here, we're not doing negative x or the opposite of x and then squaring it. Okay, we're taking our input of x, we're squaring it, and then we're taking the opposite of the answer. So let's go ahead and fill in our table for that. Let me add a little arrow here to help point it out. So when x is 0, I square it and then I take the opposite. When x is 1, I square it and then take the opposite. So that's what's going on with this. So 0 squared is 0, the opposite of 0 is still 0. 1 squared is 1, the opposite of that is negative 1. So 0, 0. But now, when x is 1, instead of going up 1, we're going down 1. Okay, with an input of 2, I square it and get 4, and then the opposite is negative 4. So now instead of 2 going up to 4, 2 is going down to 4. So you can see what's happening here is our original graph is getting reflected. All the points are getting reflected over the x-axis. For 3, we'll get negative 9. Negative 1 squared is positive 1, and then we're taking the opposite of that, which gives us a negative 1. So negative 1, negative 1. And then negative 2 squared is a positive 4, and the opposite of that is negative 4. So you can see this parabola has just gotten flipped over the x-axis. So every point got flipped over because we wound up taking the opposite of the answer. It doesn't matter that it was an x squared. If we had some other function with a negative out in front, let's say the other function, at 5 went to negative 3. The new function would go 5, and instead of to negative 3, it would go to positive 3. So it's flipping all the points, all the original outputs of the parent function over the x-axis, because we're getting the opposite outputs. Let's look at another one. We have g of x equals the square root of negative x. Now this time, we're taking the opposite of the inputs. We're not doing the opposite of the outputs. So let's make a table for our parent function here. We're doing the square root of x. Square root of x cannot take negative values in the real number system. So 0 square root of 0 is 0. 1 square root of 1 is 1. 4 square root of 4 is 2. And the square root of 9 is 3. So let's graph that. 0, 0, 1, 1, 4, 2, and everything else is going to be off my graph here. But there's your parent function, just the square root of x. Now, this is where you have to think a little bit and make sure we understand this. I'm taking the opposite of x. So if x is 0, I'm taking the square root of the opposite of 0, but that's just 0, and the square root of 0 is 0. So that's okay. But now look what happens when I try and plug a 1 in for x into here. I'm taking the opposite of 1 and then trying to take the square root. So that means I'm doing the square root of negative 1. And like I said, we're in the real number system, not in the imaginary numbers, so we can't do that. So I actually cannot get any answers when my input is a positive number, because I'm taking the opposite of the positive number, and that gives me the square root of a negative. So what I'm going to have to do is look at inputs that are negative, like -1, -4, -9. Because now, if I put -1 in for this x, and then take the opposite of that, it becomes +1, and then I can take the square root of +1 and I get 1. Should make that green. Okay. If I plug in a -4 for x, the opposite is +4 and the square root is 2. Plug in a -9 and I'm going to get a 3. So now for my new function, 0 gave me a 0. I couldn't use 1, 4, and 9. I could use -1 though and I got a 1. I could use -4 and I got a 2. And -9 gives me a 3. So you can see what's going on here. Every point is getting flipped over the y-axis. So here, instead of +4, 2, now it's -4, 2. So by putting this negative inside with the x, my parent graph is getting flipped over the y-axis. When it was outside the function, it got flipped over the x-axis because I'm changing all my outputs to be the opposite. But when it's inside the function, I'm changing all my inputs to be opposites, which makes my x's become the opposite side here. And if it was a negative x, then it would go over to the positive side. So to summarize, reflections in the coordinate axis of the graphs of y = f of x, that's our parent function, represented as follows. So if we're putting a negative outside our function, it's going to reflect our original graph over the x-axis. If we're putting a negative inside our function, like the second example, then it's going to be the parent function reflected over the y-axis. So once you think about the tables and the values in your tables, it should be pretty easy to remember.